7D, variables and expressions. So today we're going to start getting into what many math students greatly dislike about mathematics, and that's variables, using letters in our expressions and equations. So a variable is just a symbol, many times that's a letter, that's used to represent something. So let's say I have apples that I'm selling for $1 each. So I could write a very basic expression where I use, and I'm going to use a star just because I can, right, to represent the number of apples purchased. So if this star represents the number of apples purchased, that is a variable. It can change depending on how many apples I purchased. So I could write an expression that says the amount paid, and I'm going to put another thing there. Let's put a heart. No, let's put a dollar sign. There we go. We'll do the fancy double line dollar sign. So that's amount paid. And I can write this equation that says the amount paid, this dollar sign, is equal to 1, the cost per apple, times the number of apples purchased. So the total amount paid is equal to $1 times the number of apples purchased. So if I purchase 3 apples, then I can say that star is equal to 3, and the total amount paid is equal to 1 times 3, 1 times 3 being 3, so the amount paid would be $3. But that's the basic idea of dealing with variables. We're going to use some symbol, usually a letter, to represent certain values. The reason we use a letter or a variable is because these values are not set or fixed. They can change. And when we change them, we have a different number for that value. So that variable is just something that we can plug anything we want into. We can plug in any number into it, and then we can do our calculations, as opposed to something that is fixed. It was $1 for each apple, no matter how many apples I bought. But different people may buy a different number of apples. So this star was my variable. Someone could buy 3 apples, so I say make the star equal to 3. Someone may buy 12 apples, so I make the star equal to 12. So that's the idea of variables, is they're really just placeholders for numbers. When we don't know what that number is going to be, or when that number can change. And when used in formulas, that allows us to have one equation that represents a lot of different cases. Many of the things that we've done thus far, you get given a word problem and you just plug the numbers in according to what it says, and then you calculate it. And then if I give a second word problem, you plug the numbers in again, different numbers in, and you solve the problem. If I do a third problem, then we do the same thing again. We're plugging them in, but we're basically rewriting our expression or equation every single time we do it. Whereas now we're saying we can use a general formula and maybe answer multiple questions with it by just plugging in a different value for the variable. Let me give you an example. L is equal to 75 plus 42x. Gives the labor cost, L, and I'm putting that L in parentheses, so many times we're told that this is what it means and this is the variable that represents it. So gives the labor cost L for X hours. Another way that we can state it, so for X hours, meaning that hours will be using X, or X will represent the number of hours, of heating system repair. So we're given this formula, L is equal to 75 plus 42x, which describes the labor cost L for X hours of heating system repair. So the first thing we want to do is recognize the variables, and I think it's pretty straightforward here. L is a variable, it can change, it represents the labor cost. X is a variable, it can change, it represents the number of hours that are spent working on this system. And in this we see that there's actually a fixed value, right, 75. No matter how many hours are worked, that 75 is still 75. And then there's what we call a variable portion of it. This value here is 42 times X, the number of hours. So this portion is variable or changes according to how many hours are worked. Whereas this fixed portion, 75, no matter how many hours I work, we have 75 here plus that. So we have a fixed portion of the equation and we have a variable portion of the equation. So now that we recognize what the variables are and what they represent, then we can answer the question, what is the labor cost if the repair takes 2.5 hours? So I'm just going to switch to a different color here. So what is the labor cost if the repair takes 2.5 hours? All right, so there's our question. We have our equation with a couple of variables in it. We know what those variables represent, and now we're asking what's the labor cost if the repair takes 2.5 hours. Now previously without variables we would have said, oh okay, they would have told us that there is, anytime someone comes to repair your heating system, they're going to charge you $75 plus $42 an hour. If they work for 2.5 hours, what would be the cost? And you would have built it just as a standard equation, plugging things in. Now we've got this formula that relates X and L, and we're just going to look at it. It's like labor cost if repair takes 2.5 hours. What is this 2.5? Well, that's the number of hours, right? So that's X. Labor cost is what we're looking for. So we're just going to take this equation, go L is equal to 75 plus 42 times 2.5, right? Just plugging in that 2.5 for X, so we just substitute it in. And now we can do our calculations. As I reach over and grab a calculator, which hopefully works. So we're going to, order of operations says multiply and then add. So we're going to have 75 plus 42 times 2.5 gives us 105. So 75 plus 105 gives us 180. So the labor cost is going to be $180 for them to come and work for 2.5 hours. Now remember, whenever we're dealing with a word problem, it's good to say, does that make sense? Well, let's see, the labor cost is $42 an hour, they work for 2.5 hours, I'm paying $180, wow, but, oh, that's right, there's this $75 that I have to pay no matter what. So if they just came out and spent half an hour, I would pay $75 plus half of 42, so plus 21, I'd pay $96 for them to be there a half hour. Since they're there 2.5 hours, I'll get 2.5 times that plus 75. But actually, the longer they stay, the lower my equivalent hourly rate will be, because this $75 happens no matter what. They stay for a minute, or they stay for 2 days, I get paid. This $75 is just $75. So the more hours they work, the more I can split this up and say, well, it's costing me less per hour for the fixed cost involved there. Okay, so that's variables, and you can see this could be considered a variable expression or equation. I'm going to call it an equation because it has equals. If I got rid of that equals and just said 75 plus 42x, then I would call that an expression. So the difference between an expression and an equation is whether it is equating two things or setting two things equal to each other. An expression is just a relationship of values and variables that are either added, subtracted, multiplied, divide, raised to the power, taking the square root. So it's just a combination of variables and numbers put together in some way, combined by certain operators. An equation is an expression that is set equal to another expression. Now this expression just happens to be the variable L. But this is an equation because we're saying this expression is equal to that expression. Okay? So when we're dealing with this and we're dealing with these variables and such, one of the most important things that we need to be able to do is translate. So being able to translate either from words to an expression, and we could even call this an algebraic expression, because when we start dealing with letters and symbols to represent things and to act as variables, then we are dealing with algebra. Algebra just means that there's letters involved or symbols involved. So when we're looking at this and we're saying, well, I want to work with this, we need to be able to translate. We need to be able to take words and write them as algebraic expressions, or take algebraic expressions and write them as words. So the sum of a number plus 5. The sum of a number plus 5. So that's in words. If I want to turn that into an algebraic expression, the sum of a number plus 5, sum tells me I'm adding a number to the number 5. So a number plus 5, so I can define this random number. It's not a specific number, right? It's not, I'm adding 3 plus 5, I'm adding a number. Could be anything, it can change, it's variable. I can say n is the number plus 5. So the sum of a number plus 5. $21 less than twice a number. Now realize we are dealing with the English language, and in the English language there are numerous ways to say the same thing. So there are many different ways that we can say things in mathematics in English. The words that we use and such to do that. So 21 less than twice a number, we have to recognize what these things are saying. So 21 less than, if I said Bob has, let's say Bob has $10 and Joe has $3 less than Bob, isn't that saying to take away from what Bob has to find out what Joe has? So 21 less than, that's saying subtract 21 from something. Minus 21. Less than what? Twice a number. Well, what does twice mean? Twice means to double or to multiply by 2. So I got 2 times something. 2 times what? A number. So a number could be any number, right? So that's a variable. So 2 times n minus 21. Let me put this here so it looks a little better there. So 2 times n minus 21. That's just the same. 21 less than twice a number. Now notice that I put the 2 and the n right next to each other. We've said that multiplication can be indicated by a dot. It can be indicated by parentheses, right? It can be indicated by that x there. Well, when you're dealing with variables, with letters, multiplication can be indicated by just putting the things right next to each other. So 2n is the same as 2 times n, is the same as 2 times n, is the same as 2 times n. So when variables are involved, you can put them right next to each other. In fact, I can do a, b, these two variables, that says a times b. Now the reason we can get away with that is basically this is doing the same thing as the parentheses did for us. But when you were dealing with numbers, you had to use the parentheses because there was no way to tell where one number started and the other number ended. What do I mean by that? 31 times 2. Right? If I wanted to say 31 times 2, and I wrote it like this, it's 312. So we have to put the parenthesis there to say it's 31 times 2. Whereas with variables, these are the variables, a and b. We don't have to put parentheses around one of them or both of them to separate them. That's an a, that's a b. They're separate variables. So that's really what it's doing. It's really a slight modification of using parentheses for multiplication. The reason we used parentheses, the main reason, was because it allowed us to differentiate between the two factors. There are also other reasons, obviously, when we're dealing with distributive property and we have a value and we're multiplying it through a bunch of other values. But we can put them right next to it, so 2n minus 21. But if you don't want to do that, you should be able to recognize that, but if you don't want to do that, there's nothing wrong with you saying 2 times n minus 21. That says the exact same thing. So going from words to algebraic expressions, and then the other way, going from an algebraic expression and putting it in words, (24 over 19 minus 3. So we've got 24, 19 minus 3. Now if we want to put that into words, We're just going to state what's going to happen. In fact, I'm going to change this a little bit. We're dealing with variables and such. Let's make that 24 over n. So how would I put that into words? Well, really, we just want to state what's happening. So that is 24, and I'll write out the letters, the words and the numbers. 24 divided by n, right? But when I say n, we're going to say divided by a number. Divided by a number minus 3. So there is a way we can represent that. 24 divided by a number minus 3. Maybe we want to word that a little differently. Maybe we want to say 3 less than the quotient of 24 in a number. 3 less than. Remember, we used that on a previous one. Less than meant we were taking away. 3 less than the quotient of 24 and a number. The quotient of 24 and a number less 3. Take away 3 from the quotient of 24 and a number. There's numerous ways that we can word this. Three less than 24 divided by a number. Okay, so a lot of different ways we can do it. So it's just translating, it's recognizing what it's doing and putting it into words. One of the biggest things with it is recognizing what operation is happening and how to put that in words, or if it's in words, recognizing what operation it's telling you to do. The other thing is to recognize that we're going to treat the variable as a number. So don't say n, don't say 24 divided by n minus 3, but if we're putting it into words, 24 divided by a number minus 3. And vice versa, if it says 24 divided by a number minus 3, 24 divided by some variable. In this case, I chose n. A lot of times we use n because a number, n. Many times we use x because that's the standard thing. Anytime you see algebra, you seem to see x in there, right? Very familiar. And they're always trying to solve for x. So what variable I use doesn't matter. That could be n, it could be x, it could be a symbol. The artist formerly known as Prince, and the little symbol that he had there. So it doesn't really matter what variable you use when you're coming up with your expression or equation, but you will find that many times there is a set variable that tends to be used for certain things, and we'll get to take a little look at that later on.